Welcome back everyone. This will be our lecture number 5 about CIDR subnetting. In our previous lecture, we successfully subnet the 10.0.0 address, okay? And we successfully borrow bits from the second octet and third octet. Today we are going to borrow bits from the fourth octet. We know by default this is the prefix and these are suffix. But when we will borrow bits from in subnetting, we are borrowing bits from the suffix parts to the prefix parts. As we did, we successfully borrow bits from the second octet and third octet. Today we are going to borrow bits from the fourth octet. And the number of borrow bits will be 17. Okay, it means that 8 from the second octet, 8 from the third octet, and 1 from the fourth octet, while the 8 is the default. Okay, 8, this 8 is default. Only these are the borrow bits. Okay, so 8, 8, and 1. The CIDR notation after borrowing 17 bits will be 10.0.0.0/17. Okay, there is a mistake, not 17. This will be 25. Okay, because 17 is the number of borrow bits. 8, 8, 16, 24, and 25. So this is 25. The total number of prefix bits. And let's find out the subnet mask after borrowing 17 bits. The subnet mask will be this: 255.255.255.128. Remember, this is same like this. Okay, here 8 bits are on, 8 bits are on, 8 bits are on, and here only 1 bit is on and the 7 bits are off. Okay, and 128 is the value of that 1 bit. Let's find out the number of subnetworks after borrowing 17 bits. You know, we will use this formula 2 power n. What is the n value? N value is the number of borrow bits. So how many bits are borrowed? 17. 2 power 17. Okay, 2 power 17, it's equal to this. Okay, this is the total number of subnetworks. It means that this 10, which was the main network, is now divided into how many subnetworks? Subnetworks. Okay, this was the main network and these are subnetworks. Okay, how? Maybe you guys are thinking that how this much subnetworks. Don't worry, we will do calculation of this. Next, let's find out number of hosts per subnetwork. It is 2 power h minus 2. What is the h value? See, my dears, already 25 bits are prefix. Okay, added to the prefix part. So what is the total number of bits? 32 minus 25 is equal to what? 7. So 7 bits are remaining for the host. So the h value will be 7. 2 power 7 minus 2 is equal to 126. 126 host will be there for each subnetwork. Okay, now let's find the range of each subnetwork. This is important and most of the students get confused in this part. Remember, as you already learned in previous lectures, that we have to see that in which octet we have the on and off combination. You can see that here we have on and off combination and the fourth octet. So the first bit, which means one bit is borrowed and that is on. The rest are what? Off. So take this 1. 2 power 1 is equal to what? 2. And what is the full range of the fourth octet? 256, from 0 to 255. It's equal to 256. Divide by 2 is equal to 128. Okay. Yeah, and you can also find out from here 128 minus 2, 126. So now the range of first subnetwork subnet 1 10.0.0.0 10.0.0.127. This is the first subnetwork. You can see from 0 to 27 it's equal to what? 128. Okay. Next subnetwork, subnet 2, 10.0.0.128, 10.0.0.255, and subnet 3. Now this 255 will become again 0. Okay, and this 0 will become 1. 10.0.1.0, 10.0.1.127. Subnet 4, 10.0.1.128, 10.0.1.255. Next time this 1 will become 2. Okay, so on until this will become 255, then this 0 will become 1. Okay, until 255, then that 1 will become 2, and so on, like this. Here at the fourth octet we have 2 subnetworks. At the second octet we have 256 subnetworks, and in the second octet we have again 256 subnetworks. Let me calculate this. It's equal to 131,072. It's same like this, as I told you before, that the number of subnetworks. So you can see, my dears, here in the fourth octet we have the range was what? 2 subnetworks, as we can see. Divided 2 ones are 2. Okay, because we borrow 1 bit from there, 2. And the third octet, sorry, total belongs to the prefix. In the second octet, total belongs to the prefix. So 2 multiplied by 256 multiplied by 256, 131,072, the number of subnetworks. And in each subnetwork the number of valid host is 126 and the number of total host is 128. So this was borrowing 17 bits. Now let's borrow 18 bits. Number of borrow bits is equal to 18. Okay, what will be the CIDR notation? The same IP I am going to use. This will be 26. Okay, 26 mean what? 26 mean 8 bits is here, 8 bits is this, and here, and 2 bits are here. So is equal to what? 26. 8, 8, 8, 2. Okay, and the subnet mask will be 255, because 8 bits, 255.192. 192 is what? From this it is the decimal equivalent of what? 2 borrow bits or 2 on bits. So this will be the subnet mask. number of subnetworks is equal to 2 power n. What is the n value? We borrow how many bits? We borrow 18 bits. So 2 power 18, okay, is equal to the number of subnetworks. Number of hosts per subnetwork, very simple, 2 power h minus 2. 2 power h minus 2. What is the h value? 2 power 6 minus 2. Okay, so 2 power 6 is equal to 64 minus 2 is equal to 62. 62 means this is the number of hosts in each subnetwork. And how you can find the range? That is simple. Use the previous formula. But if you will not use the previous formula, this is very much simple because we are at the 4th octet. We already know that in each network we have what? 64 number of hosts. So without putting the values in the formula, you can also find it. Let me try. For example, subnet 1. So 10.0.0.0 64. So 10.0.63. First subnetwork, subnet 2, 10.0.0.64, 10.0.0.127. Subnet 3. Don't be confused here, okay? If you are confused, put the values in the formula. Like the 4th octet is what? We borrow how many bits from the 4th octet? We borrow 2 bits, you can see here. So 2 power 2 is equal to 4. And what is the total range of the 4th octet? 256. 256 divided by 4 is equal to 64. So that is the 64 from 0 to 63, 64 to 127, and so on. 10.0.0.128. If you are confused, what will be the next? Simple. Put calculate here, plus here. 0, 7 plus this 11. 1 is here, 3, 6, 9, 191. 191. Subnet 4, 10.0.0.192, 10.0.0.255. Simple. If you want to find out the number of the first valid address and the last valid address, simple. Increase one here and decrease one here, like this. 10.0.0.93 is the first valid, and the very last valid is 193. 254. This is the last valid address. The first, this address and this address, this is the network and this is the broadcast. You know this. Okay, guys. Remember, in class A, we can maximum borrow 22 bits. This is equal to 22. Okay, 22 mean what? 8, 8 and 6. 8 from the second octet, 8 from the third octet, and 6 from the fourth octet. And 8 will be the default. 8 are the default. So now 8 plus this, the total number is equal to how much? 30. So remaining host bits are how much? Is equal to 2. Only 2, okay? And we cannot borrow more than 22 bits, because when we will borrow more than 22 bits, then this number will be decreased. Like it is 2, so 2 power h minus 2. Put this in the formula. 2 power 2 is equal to 4 minus 2 is equal to 2. Okay, if we will borrow 23 bits, suppose it is not possible, then what will happen? How many host bits will be remaining? 1. 2 power h put it the formula. 2 power 1 is equal to 2 minus 2 is equal to 0. It means it will not give us any host address. That's why we are not able to borrow more than 22 bits. Okay, so my dears, we practice only this address, the private address of the class A, but no problem, you can practice any address from 1 to 126. Use the same method and do the subnetting, but keep in your mind that the subnetting which we done is only for the learning purpose. You have to learn it in this way. This was the easiest way, but for example, but when you will require to do it practically in the organization, that is not like this. That is the requirement based. Like for example, you will have a specific IP address and your requirement will be a particular number of networks having a specific number of host addresses, so you will go accordingly. Okay, but don't worry, I will also cover that inshallah in our next lecture. We will go to class B subnetting, then class C subnetting, then after that I will have a comparison of CIDR and VLCM. I will solve a practical example by both CIDR and VLCM, and after that we will go and we will do some scenario based subnetting, and I'm sure that after this session you guys will become subnetting guru. Okay, inshallah. So thank you very much. See you in the next lecture.